So the next part of indicator 11, we are going to talk about zero and negative exponents. Our learning target, I can use the zero exponent rule and the quotient of powers property to simplify expressions with zero and negative integer exponents. And then my vocabulary for this lesson, negative exponents and the zero exponent rule. So, um, the exponents of a zero, basically, we are going to use the zero exponent rule to simplify expressions containing exponents of zero. So, just when we're going to look at this, we'll see what the answer is going to be in a minute. But any non-zero number to the zero power is always equal to 1. Okay, so I've kind of drawn out a format as to why for you all, but any non-zero number to the zero power is equivalent to 1. And why is that? Because let's look at the pattern that I have just drawn out over here. All right, and let n represent any non-zero number. So this n is representing any non-zero number. All right, and so the pattern in the table shows that as you decrease the exponent by 1, the value of the power is divided by n each time. And so by extending this pattern, look what's happening. Each time I am dividing by n. So if I had n to the fifth power, that's any non-zero number is represented by n. All right. So if I'm dividing by n, this is going to become what? N to the fourth, n to the third, n to the third, which is n cubed, n squared, n to the first power. So as you can see, the power, because I'm dividing by n, you are subtracting 1 from each, right? So it keeps going down like this if you look at the pattern. And then n1 minus 1, I get n0. And see what's happening. What is n divided by n? Is 1. So any number divided by itself is going to give me 1. And that is why, if you think about it, n to the 0 power is always equivalent to 1, because it's like saying you're taking a number and dividing by itself. All right, so just look at this pattern, and that's where we are going to end up with. So which is n to the 0 power is always equivalent to 1. Okay, so let's look at some of these numbers that I have here, and we are going to see which of these are equivalent to 1. Okay, so 2 to the first power, is that 1? No, because 2 to the first power is going to be 2. So this is not correct. All right, 1 squared, what is 1 times 1? It is 1. So this is correct. All right, 2 to the 0 power. Yes, and I just told you that based on the zero exponent rule, any number raised to the 0 power is going to be 1, because it's like saying 2 divided by 2 is going to give me 1. So this is correct. 1 to the 0 power, again correct, because this is going to give me 1. 0 to the first power, no. Okay, that's not going to equal 1. And then I have 1/2 to the 0 power. So basically, what is 1/2 divided by 1/2? I am going to get 1. So this is correct. Anything to the 0 power is going to equal 1. All right. Now, so just if we simplify anything, if I give you 12 to the 0 power, what is the answer going to be? Any number raised to the 0 power is 1. So here my answer is going to be 1. Okay, so anything raised to any non-zero number to the 0 power is 1. What if I give you with a variable? What if I say x raised to the 0 power? What is that? Again, is basically the same thing. Anything raised to the 0 power is equal to 1. Okay, whether it's a variable which is representing, what is a variable? Variable is nothing but something that is representing a number. Okay, so any number, a non-zero number raised to the 0 power will equal to 1. So please just remember that rule based on the pattern that I've just shown you. Okay. So a negative exponent. Let's talk about what a negative exponent is. And I am going to try to pull this a little this side so you can look at that part of the board more clearly. Okay. So I'm going to use that table over there to show you an exponential form or the standard form. So if I look at this, yeah, let me try to get this closer. Okay. So let's say I have the exponential form and a standard form, and I'm trying to see a negative exponent. What is that? It is the result of repeated division, basically. You can use negative exponents to represent very small numbers. And every time you divide by 10, the exponent decreases by 1. So let's say in the exponential form, I have 10 cubed. Okay, so if I'm saying 10 cube, what does that mean? That basically means 10 times 10 times 10. And what is the standard form? Standard form is a number as is, so this is equal to 1000, right? And then if I'm dividing, I'll keep dividing by 10. So let me just go here. I do 10 squared, which is 10 times 10. That gives me 100. So I am dividing by 10, dividing by 10, and that's what I'm going to continue doing. And so then I have 10 to the first power, which is is just 10. All right. So my standard form is 10. And then I have, again, I'm dividing by 10, so I get 10 to the 0 power. um, all right, 10 to the 0 power. So what's happening when I'm dividing by 10? What is 10 divided by 10? I get 1. Anything to the 0 power we've already done is equal to 1. Okay, now let's see. So this is going from 3 to 1. I have 0, and then next I do 10, negative 1. 10, negative 2, 10, negative 3. All right. So now we are going the other way. And that's because what are we doing? We are dividing by 10 constantly. Divided by 10, divided by 10. This is all we are doing. Okay. And so when I do 10 to the negative 1, what does this become? This is 1/10. This is 1 over 10 times 10, which is 1 over 100. This is 1 over 10 times 10 times 10, which is over 1000. So I just wanted you to see this format um, in order to get an idea as to what we're doing. So 10 to the negative 3 power, as you can see, is going to be 1 over 1000. All right. So if you look at that pattern, and then I am going to go ahead and show you some problems on this side. Okay. Um, so negative exponents. As if I am trying to express, and I just showed you this pattern here. So if I'm trying to express um, negative exponent using a positive exponent. Okay. So if I say 6 to the power of negative 3 cubed, and if I need to use a positive exponent, so we're going to look at, hey, what is the multiplicative inverse of 6? And I know that the inverse of 6, multiplicative inverse of 6 is what? It's going to be 1/6, right? So therefore, this number, 6 to the power of negative 3, is actually going to be in a positive form. This will just become the multiplicative inverse, which is going to be 1 over 6 cubed. 1 over 6 cubed. So if I'm trying to express it using a positive exponent, I just use the multiplicative inverse, and that's what my answer is going to be in the positive exponential format. Okay, so let's write b negative 4 in the as a positive exponent. So again, multiplicative inverse of b is going to be 1 over b, right? So 1 over b raised to the fourth power, and now that is written with a positive exponent. All right. Now, if I have a fraction, and let's say I have um, 1 over c to the fifth power. Let's say I have that. And I need to express this fraction using a negative exponent. So the definition of a negative exponent, again, what is the inverse of this? Is of 1 over c. The reciprocal is what? C, right? So c negative 5. So the exponential part is negative 5. So 1 over c to the fifth power can be represented using a negative exponent and it's written as c to the power of negative 5, and that's as simple as it gets. Okay. So let's say I have 1/8 cubed, and I need to express this fraction using a negative exponent. So again, the reciprocal, which would be 8, and the sign is going to become negative 3, or 8 to the negative cubed as an exponent. Okay, the power of negative 3. Now, sometimes you are given a problem such as you have, say, 5 cubed times 5 to the negative fifth power. Okay, so we are now going to look at this, and looking at this, I'm going to use the product of powers property. I can see that the bases are exactly the same, so I am going to write the base as is. And the product of powers property tells me that if I have numbers that I'm multiplying, what do I need to do? I need to add the powers, which we've already done before. So this is 3 plus negative 5. 3 plus negative 5, because I'm using the product of powers property. And now I can see that these are opposite signs. So it's going to be 5 and negative 5 minus 3. But, well, absolute value of negative 5 is 5, minus absolute value of 3 is 3. And so the sign in front of the bigger absolute value, I get negative 2. All right. And so now I'm going to convert this using positive exponents. So reciprocal of 5 is 1/5, and I have this, the negative is going to become just 1/5 squared. And if I am going to simplify this is going to be 1 over, what is 5 times 5 is 25. And so 1/25 is my answer to 5 cubed times 5 to the power of negative 5. Okay. Now, why is the answer not left as 5 to the power of negative 2, or in this format? And that's because a simplified answer does not contain any negative exponents. A simplified answer does not contain any negative exponents. If I'm simplifying it, I need to go down to the positive exponents and then solve it. Okay. So let's say I have a problem in which I am simplifying n minus 8 n to the power of negative 8 times n squared, Now again, I'm going to use the product of powers property, and I am going to, the bases are the same, and I am going to add the exponents. Okay, opposite signs. So I'm going to subtract the smaller absolute value from the bigger one. So 8 minus 2 is 6. And the sign in front of the bigger number is negative. So n to the power of negative 6. I cannot leave it like this because it's not the simplified version. So I have got to convert this to a positive format, and that gives me 1 over n to the sixth power. And there is my answer. Okay. Now, I might also have a problem given to me with negative exponents. So if I have w to the power of negative 1 and I have w to the power of negative 4. So in order to begin solving this problem, we are going to use the quotients of powers property. Now, I know that if I'm dividing, like if you remember in multiplication, we were adding the exponents. In division, we are subtracting the exponents. Okay, so this is going to be W, and since the fraction line means division, so I am going to subtract the exponents, and I get minus or negative 1 minus negative 4. And we've done this before. When you have two negative signs next to each other, you are removing negativity, so it becomes positive. So you're adding the opposite basically. So this is negative 1 plus 4, and I get W. What is 4 minus 1? Is 3. So this is 4 cubed is my answer for this problem. Um, both of the original exponents are negative, and so why is the exponent in the simplified expression positive? Because remember, to subtract the exponents, you're simplifying negative 1 minus negative 4, and that becomes negative 1 plus 4, which equals positive 3, right? So let's do one last problem. And if I give you a question such as simplify 11 squared over 11 to the fourth power. Okay, so remember, based on what we've learned before, since this is division, I am going to write the same base, and then I am going to subtract the exponents. 2 minus 4, and 2 minus 4, I am going to get 11 to the power of negative 2, and then I am going to do the reciprocal of that, and I get this is equal to 1 over 11 squared. And 1 over 11 squared means what? This means 1 over 11 times 11. And that gives me 101 over 121 as my final answer. Okay, so just remember this lesson, you just got to know what the zero exponent rule, and any non-zero number to the zero power is equivalent to 1, and we've done that. Okay, and also just remember that when we are let's see, when we have a negative exponent, just remember that you are, in order to convert it to a positive exponent, you are just doing the reciprocal of that number. Or if you're converting a positive one to negative, again, you're finding the reciprocal and then just flipping the sign. Okay, so and that is to do with zero and negative exponents. And that concludes our indicator 11. And then in indicator 12, we are going to get into scientific notations. All right. Have a great day, everyone.